Hello everyone, this is Xiaoqian Sun. This is my homework, my project, and I will go through the detail one by one as the requirement to make sure I get as many points as possible. Excuse me. So the first part is use case. This is a computation at machine hack, and this is a link. Uh, so this is problem description. It's about the food inspection department. They have different inspections on some restaurants or daycare or school to make sure their food is safe. And they want to, excuse me, predict where they should focus most so that they can arrange the next inspection to use people more more efficiently. So in the computation, we got a subset of the data set with information of food quality checks conducted on thousands of facilities that serve food across multiple cities. So the object is to predict whether a facility will pass or fail the inspection based on a number of factors. Okay, this is the dictionary. We have a UUID, a date of the inspection, a license number. This refers to different license, facility ID, and facility name. To my understanding, it's just like facility name is Chick-fil-A and the facility ID is Chick-fil-A at a certain location. Type is if it's restaurant or school or daycare. Street, city, state, location ID. These are all location information. And there is another location information called geolog. So it's confusing. I will talk that later. And reason, the primary reason for the inspection. Section violation, laws violated by the facility. Risk level, the level of risk the facility poses to the consumer. Inspection results, that is the final label we need to predict, and they are numbers in the data side, like this. So the computation provide a trained data set with label and a test data set without label, and a sample submission. So after the homework, I submitted my uh, model, and well, the ranking not good, but I will talk that later. This is the data preview. ID, date, license number, facility ID, facility name, type, straight, location information, reason, section violation, risk level, and the inspection result. 4 is pass. 6 is shut down. Okay, let's go back to the notebook. So this is a use case. And by the way, I have to say I'm going to use a library called Pandas Portfolio for EDA, and so I need to install it. We skip this part. Okay, the second point, data side. So I download the data side from the from Machine Hack website. Yeah, it contains 3 forms and just mentioned. I use Panda to read the I use pandas to read the Excel file. Now, if you Google, you will find to use Spark to read Excel file is a little bit tough. Okay, that is the second point. So the third point is data quality assessment, and I combine data quality assessment, the data exploration, and data visualization in the same part. I think, yeah, I find it's hard to separate them. So first of all, load the file. I specify to load all the data in string so that, well, I will do some data manipulation and define the type in Spark data frame. So this part, we read the pandas data frame and convert it to Spark data frame and check the first 5 rows and then define the data type. So ID, UUID is integer and the date is timestamp. And the other part, they are all category features. So I define them as string. So this part, I assign correct data type to different columns. So the reason I do that because I need correct data type for EDA to use pandas portfolio. And here, well, in production, if I use Spark data frame, I will get a sample of the data frame and convert it to pandas data frame for EDA. Since the data set we have is very small, so I just get all the data from Spark and convert it to a pandas data frame. And then generate the pandas portfolio like this. So we have 15 variables. The number of rows has missing values. The number of cells has missing values. Excuse me. And duplication rows and category features. 13 category features and 1 date time features and 1 numerical feature, which is the ID. So ID is UUID. It has 100% unique value, so we don't need to care about this. I will remove this in the model when we when we clean the data set. And this is the date. We have already converted the string to a timestamp format. And there are 53 missing values. And you can see the distribution of the date is kind of uniform, from 2009 to 2019. You can see the distribution in a ladder histogram. And the license number is just it has been converted to integer as just like a label encoder in label encoder in scikit-learn. There's some unique. There are 23 unique numbers, 23% unique values. So some duplicate values. Facility ID. Also, some facility has been checked for different license for multiple times. Facility names. If some facility has been inspected for multiple times. And type. So the major is restaurant. And then grocery store. And some other values and missing values. For the street part, well, the category is pretty diverse. Yeah. is high cardinality, too many unique values. The city, only two values, and this is the major value means, well, all the most inspections, 99.8 inspections happens in one city. So this may be bad for data has city with this value, may cause overfitting. Also state, so all the inspections happen in one state. No, 99.9% data inspection happen in one state. The location ID, it seems the location is encoded in a different way. And about the reasons, this is the reason of the inspection. This is the section of violation. It's also encoded. Nothing special. Risk level. Most risk level is high to human. And also the geolocation. This is confusing part. Why we have so many location information. The inspection result. Yeah. 4 is pass. More than 43.9% inspection pass the inspection. It's something good. And about the detections, it's all about ID, so we ignore this part. So anyhow, we have missing values, but not too many in different category features. And the thing I care about is the missing values for date. So why there is missing values for date? So I just try to find these missing values. Use the Spark data frame, I can filter from this data are unknown. So I just get the ID to a list and use the pandas data frame to locate those ID and find the unique value of the date. They are strings. Now, this what we find for the missing values of date. But in original data, there are values. And after I check, well, now the February 29th, on 2011 and 2015 is, there's no 29th. I don't know why they have the data. So I just remove these 53 rows. Okay, and then count again to make sure the rows has been removed. And then fill all the missing values with non-values. They are all strings, so I just fill a string. Cool. This is a part of the three key points: data quality assessment, data exploration, and data visualization. So you see, it's pretty simple to use Pandas Portfolio to do this. Otherwise, you may have a lot of code to explore different columns. But here, you only use one command, and the visualization is pretty integrated in the notebook. Okay, the next part is at least one feature engineering. So I have filled the missing value, but never mind. I don't think it's feature engineering. So what I did for this is to extract the date week and week of day from the date information. So in production, I always use a tool called feature tools, which is more friendly to pandas data frame. And this feature tools library well this library, we'll use a concept called deep feature synthesis. So, for example, I have described this in the ADD file. So, for example, you can get uh, the most common inspection result of certain facility name or ID before this inspection. I mean, maybe the facility passed the previous inspection, and it may have higher probability to pass this time's inspection. If it fails, if it failed previously, maybe it will have higher probability to fail this time, And also, you can build a feature called the number of certain facility type in a location. Maybe in some location there are more restaurants, and this restaurant has high probability to pass or fail an inspection. This may affect the result of inspection in this small region. So we don't know that, but this deep feature synthesis can prevent data leak. You can hold all the data information. Okay, so here I define a new column called day of week, and it's a numerical feature. And this is a feature called week of year. It's also a numerical feature. So this is the result. And here it is. These last two columns are the two data we just generated. 1 is Monday, 7 is Sunday, 3 is Wednesday. Cool. Okay, and then we removed useless data column, which is ID and date, and then cast the new features we got to numerical to integer, and also the final label, the inspection result, also integer. Okay, so this part is about feature engineering, and now we have ABT. So in ABT is analytical base table, well, which is the term I use in my work all the time. But that is the data side for training the model. Okay, next part is select a model performance indicator. So I just simply choose accuracy. It's a multi-classification problem. No, at the beginning I also try to choose log lose as the indicator because for the computation they use log lose. But when I try to do that, to calculate that, use the Spark, and for no reason, well, I just have to wait for a long time and the notebook died for no reason. So I just skip that indicator, only use accuracy. Okay, and the next point is at least one traditional machine learning algorithm and one deep learning algorithm. Okay, so this is the traditional machine learning algorithm, and before I train the model, I calculate the damming feature. So for categorical features, we use a string indexer and one hot encoder to generate dummy features. And for the numerical features, we just combine this category feature has been transferred to dummy features with this numerical feature with vector assembler to feature column to a new column. So this is the pipeline. Indexer and encoder are for category features. This is string indexer. This is one-hot encoder. Assembler will combine the category feature and the numerical feature together to generate this feature column. And then we have a label. The label is the inspection result. And this function will return a data set with clean feature and label, only two columns. So I define the category features and the numerical features and use the function to get a data set for training. And here I choose logistic regression and very basic parameters and to train the model. I use the whole data set to train the model because I will use the test data later to submit the computation. But it may not be a good idea because I may get overfitted data model. So logistic regression is pretty fast, and I have tried different algorithms, but they took longer time, much longer. So to finish this assignment very quick, so I just choose logistic regression. And the accuracy is 91%. It's good. And it also requires to do some difference feature engineering and compare the model, the last point. So I just removed all the location information from the data set. No, I think the location information is redundant. Uh, I'm not sure about that, but I just feel I have sense of that. So I removed all the location information and only keep the category feature and macro feature and do the same thing and train the model again. See, I got 93.999, 94% accuracy is much better. So I use this model to generate the data set and submit to the computation. And also it requires one deep learning algorithm. So I'm not good at Keras. I try to train that. I try to train a model use Spark data frame with Keras, but it requires system ML, which is I still haven't learned pretty well. So I just convert the Spark data frame to pandas, and to train the model, it's much easier for me to finish this work. And I will learn some system ML later to do more practice. So here, I just build a very basic model, very basic, and the input dimensionality and the final classes is got from the data frame. And this is summary of the model and train the model and the metric is accuracy. It is not good. And so the accuracy is only 53%. And after I removed all the location information with the same model, I got only 19% accuracy. It's pretty bad. I will find some. Yeah, if I spend more time on this, I could definitely improve the performance. But in the traditional machine learning algorithm, I already got a good enough result. So I did not spend more time on this. Time is busy, especially with 2Ks. Okay, so that's all about this notebook. And it also has please assign 1 point for each item below, which properly covered in the ADD. I also have the ADD file here to detailed uh, explain how I choose the technology about the data quality assignment, about feature engineering, about algorithm, about framework, and the feature, a model performance indicator. And finally, I will show my ranking result. So here is me, 40. I'm in the location 40. It's not good. Now this is the log lose. I got 0.39957. And the best one is here. Amazing woman. Pretty wonderful result. That is homework. Yeah, I will not spend more time on this. That's all. That's my assignment. And I hope you enjoy this. I hope you find some useful technology, maybe good for your work. And I hope you have a wonderful day. Bye bye.